Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. I am Desire, and today we have got Benedictus, who has completed the course ROS 2 Navigation. He'll be giving us a presentation, and as we always do, we'll see a demonstration of the real robot first. So we'll see his code base running on the real robot, and then after that we'll get into the details about his presentation, whether he's using slides or just a code review. And towards the end we'll get to ask him a couple of questions to really understand how he did what he did, and also get the logic behind it. Okay, I'll now hand over the platform to him so he can begin his presentation. Alright, Ben, whenever you're ready.
All right. Hello, everyone. My name is Benedictus, and in this occasion, I will present to you the ROS2 navigation project that I've did. Currently, we're waiting for the real robot. It's about 1 minute.
Alright.
So while we're waiting for that, I will explain a little bit about the packages that I've did.
Mm-hmm.
So the first thing I did is obviously the mapping. The mapping is the process in which we make the map. And after we make the map, we create a map server in which we store the map.
Mm-hmm.
And then after that, we can do the localization. And after we do the localization, we do the path planning.
Okay.
And there is also some custom interfaces that I use basically to get the coordinates in the map and to save it. And this is a custom service that I did.
Mm-hmm.
So yeah, Uh, okay, in about a few seconds, we will try to connect to the real robot.
Alright.
Okay, so now I'm gonna move the robot to a more suitable position.
I think you might have to use the tele.
Oh, the tele.
Yeah, because the
Oh, all right.
yeah.
Oh, it's not working as well.
It's not
Hmm.
responding.
Yes, it's not responding.
Can you try reloading? Uh, okay, just
Oh, yeah.
okay.
I will try to disconnect and connect it back.
Yep, yeah. I think it's probably because of where it is. So, but we'll see. It must move
All
backwards
right.
though. Yeah.
Yep. All right. I will try to connect it again.
Okay.
Okay, now it's working.
Okay. That's good.
Let me move it to suitable position first. All right. Now we are gonna open the RVs
Mm-hmm.
basically to visualize what the robot sees. And I will open the configuration that I've made basically for localization and navigation.
Okay.
All right, currently it's empty. Now we have to run the map server and the localization.
Mm-hmm.
All right, as you can see now, the map is loading. This is the map that I've made previously from
Mm.
the real robot.
Okay.
So I can just go ahead and use this. It's pretty similar.
Okay.
So yeah,
Okay. So it was made with the real robot, right? Not in simulation.
yes, that's correct.
Okay, that's good.
Now the next step is to post estimate. So basically, it's over here. And as you can see, there are particles scattering. We want to localize the robot so that the particles are closer to the robot.
Mm-hmm.
So to do that, we just have to move around a little bit. And yeah, as you can see, it's getting closer to the
Mm-hmm.
real map,
Mm-hmm.
the laser reading as well. Yeah.
So you're helping it out, figure out where exactly it is.
Yes, that's correct.
All right, that's
So
good.
for now, I have to do it manually.
Mm-hmm. Okay. How else would you do it? Since you said for now you're doing it manually, yeah.
Yeah. All right, we'll just do one lap of it and we'll get to the next step.
All right.
Yeah, as you can see, the particles are getting closer to the robot in
Mm-hmm.
the frames. So, all right. Uh, Now we see that the robot has been successfully localized.
Okay.
So the next step is to,
There's a little bit of offset, but I don't know if you.
yeah, there's a little bit of offset, but that's good enough, I guess.
All right. Yeah. Let's go for it.
So basically, we have the localized version. Now we want to try the two goal pose. To do that, we must call the path planning package.
Okay.
So let me open the command. Okay, now we're waiting until it's ready.
Okay.
Okay, looks like it's ready now. So right now we'll try the two D goal pose. Basically we select a point in the map and the robot will try to navigate.
Mm-hmm.
For example, we try this point, and as you can see, the robot's now trying to, oops, yeah, trying to navigate. But yeah,
Uh-huh.
the disadvantage with this is that if the map is changing a little bit, then yeah, it won't see the obstacle. So that's the disadvantage. But as you can see, it's working. So I
Yeah.
will try another pose.
All right.
For example, here, yeah, as you can see, the robot will move over there.
Okay. Okay. That's good.
Now, the next thing is basically we want to select a few points in the map, and we want to use those coordinates as like a target
Mm-hmm.
that we must reach. So the first point is the first corner. It's right over there. Uh, Let me just move the robot there. So basically, I need to move the robot to the point and then save the coordinates or the pose.
Mm-hmm. Okay.
So this is the first corner. And to save it, I have to basically call the service. So I did some copy pasting here just to
Mm.
save time.
Yeah, it's fine. I would do the same thing
Yeah,
too.
yeah, this is the first corner. So basically, I'm calling the save spot and the custom interface that I've made.
Mm.
So I will copy this. And as you can see, it has been saved. And the next spot is the pedestrian spot, which is near the crossroads over there. So
Mm-hmm.
I'm gonna move it a little bit. Yep, it's right over here. So I'm saving this spot as pedestrian.
Okay.
And yeah, it's successful. And the last spot is the second corner, corner number 2. It's right over there. So I'm just gonna move that obstacle a little bit, if you don't mind,
Mm-hmm.
just to be clear. Yeah,
And I get it out
yeah,
of the way.
yeah. I don't want to. I don't want the robot to crash.
All
So
right, it's
yeah,
fine.
this is the third spot, corner 2. We'll just copy and paste this. It is safe, and now we have 3 spots. Uh, we want to end it. Basically, we want to save the file only with 3 spots. We
Mm-hmm.
use the end label.
Okay.
And now you can see that there is spots.txt.
Okay.
This is basically the coordinates for each position.
Right.
So for this to work, we need to basically modify the parameters file. So
Okay.
it's located in the project path planning, in the config directory,
Mm-hmm.
the spot list. So let me open that up again. So for my case, I just hard code all of this.
Okay. Okay.
So for the first position, this is from the previous test that I did, and it's working.
Okay.
So hopefully this time it's working as well.
Yeah.
So this is the pedestrian. Let me just copy and paste this.
Yeah. I see you've got position there. You probably must remove one of them.
Yeah, right now is the second corner.
At the very top.
Yep. Yeah, I have to modify it manually. So now it's modified.
On corner one.
Sorry.
On corner one. Corner one, you've got
Yeah,
position colon, position colon.
yeah. So the next step is to basically
I think you didn't get
compile
what I
again.
said. I under corner one, right?
Can you repeat it?
On under corner one, just double check.
Oh yeah. Yeah. Thank you.
All right.
Yeah. Thank you. I almost missed that.
Yeah.
So yeah, the next step is to compile the package again, just to make sure the file is updated. So let me do that in a while. So we will only want to compile the package for the path planning,
Mm-hmm.
path tracking. Oh, there's a little bit of typo.
Mm.
All right.
All
Now
right.
we do the source batch. Now, to call the to move to the spots, we actually have the action client. So we need to send a goal to the action client. And yeah, I'm just gonna do the copy paste again because it's much faster.
Mm-hmm.
So for example, we want to move to corner 1, right? It's still, the navigation is still running. So now it's trying to move. And in the ROS, yeah, it's trying to select the best path.
Mm.
So yeah, it might be struggling right now. So let me stop that.
I see that.
Yeah. Yeah, but right now it's already already reached the
It's
goal,
yeah.
so
It
it's
says
goal 16.
it does say go succeeded, but then well, the way it went about it, right? Yeah, that's what we're worried about.
Yeah, basically we ideally we have to remap it, but yeah.
Mm-hmm. Yeah,
So
cause
let's try another spot.
I think the problem with moving obstacles, right? It's
Yep,
and I
that's
think that's
correct.
also, if you think about it, that's why we have obstacle avoidance algorithms, but they have to be really good. So yeah.
Yes, that's correct. So let me try another spot to the pedestrian in the crossroads.
Mm-hmm.
let's just open up the RVS because we can see how the path planning works. So yeah, as you can see, there's a green line. It's basically the path that the robot is taking. So
Mm-hmm.
yeah, another issue with this is that it only moves uh, to a certain distance from the exact spot. So it's not to the exact spot, but there's like a tolerance for it.
Okay.
So let's try another spot, the corner two. Let's see how it looks like in the RV. So yeah, it's now tracking the path that I already made.
Mm-hmm.
Yeah.
Okay.
So yeah, as you can
Looks
see, it can move to the spots.
looks pretty good. Yeah.
So I think for the navigation, it's a success, but yeah, it needs improvement for the obstacle avoidance.
Yeah, could have
And
been
yeah,
better. Yeah.
all right. So I think for the real robot, that's it.
All right.
And
All
I'm
right.
gonna continue with the presentation.
Sure. Sure. Let's go.
Okay, let me. All right. A little bit about myself. My name is Benedictus Christo Geroda Cinun, and I'm a PhD student in electrical engineering from University of Houston. I
Mm-hmm.
just recently got admitted spring 2025. And my research interests are robotics and control theories. And for our project today, it's navigation. So there are three main objectives that we want to make. So
Mm-hmm.
we want to create a map, and we want to use that map to localize the robot.
Mm-hmm.
And finally, we want the robot to basically navigate the map.
Right.
And the first thing that I did is basically uh, I create a new package for the mapping,
Mm-hmm.
uh, in which I make the cartographer launch. So basically, to create this map, I need to manually move the robot around the map.
Mm-hmm.
So this is get I get this from the RVs, uh, and then the top image is actually the image from the simulation. So
Mm-hmm.
as you can see, it's more perfect than the bottom image, which is the real map.
Yes. Yeah.
So yeah, uh, the next step after we do the mapping is to do the localization. Basically, we want the robot to know where it is.
Mm-hmm.
So basically, I need to create a conf directory to store the AMCL configuration, which is
Mm-hmm.
the adaptive Monte Carlo localization.
Mm-hmm.
And here's a little bit video in the simulation. It's basically the same thing in the real robot,
Mm-hmm.
but I think it works more smoothly in the simulation.
Yeah.
So yeah,
Perfect
it's the same
environment,
thing.
right?
Yeah. As you can see, the particles in the map are at first scattered, but after I move the robot around, it's much closer to the robot.
Mm-hmm.
So the next thing is navigation. So for that, we create a new package again. I name it a project path planning, and I created config directory, and I create the files to store the parameters like the behavior tree and so on and so forth.
Mm-hmm.
And I create a launch file to run all the nodes simultaneously.
Mm-hmm.
And to do the navigation, I open up the RFS and I select the goal, the
Mm-hmm.
goal coordinates. So this is basically the same thing that I did for the real robot. But yeah, in this scenario, in this simulation, it's much more perfect. So can create a more suitable path because the obstacles are uh, in a perfect condition instead
Mm-hmm.
of in the real robot, there's a little bit scattered.
Mm-hmm.
So the next thing I did, uh, I want to set the target uh, programmatically. So basically, I want to save the spots, the coordinates or the pose of the spots, and I want the robot to move to the spots.
Mm-hmm. Mm-hmm.
So basically, this is the same thing that I did. Basically, I'm calling the service to save the coordinates of each spot.
Mm-hmm.
So yeah, this is the custom interface that has been used. And after saving the spots, it will be stored in a parameter file in the YAML file. So yeah, that's what I did also in the real robot as well as in simulation.
Mm-hmm.
So yeah, this is the same thing that I did, but this time is for the simulation. And yeah, this is basically calling the position that I want to reach.
Mm-hmm.
So we create an action client and we send the goal, which is the coordinate of each point.
All right. All
So
right.
the conclusion from this project is that, first of all, the map can be successfully made and be saved for later use.
Mm-hmm.
The second is the robot can localize itself within the map. And third is the robot can navigate the map and create a path which avoid obstacles in the map. And the fourth thing is the robot can move to a certain predefined spots on the map. So basically, the spots that we have saved.
Mm-hmm. Mm-hmm.
And for the future works, uh, as you can see in the real robot previously, so the obstacles are ever changing, and sometimes it's not detected correctly when we are mapping.
Yeah.
So we can implement various control strategies to basically avoid the obstacles in real time. One of which is control barrier function. It's a little bit high level, so this it is not used for the scope of the project.
Mm-hmm.
Uh, I think that's it. Thank you for watching and listening.
All right. Thank you very much, Ben. Very
Yep.
nice presentation. And you did take us through what is happening, what were the objectives. So it's very nice and clear. All right.
All right.
I've got a couple of questions. First of all, I'd like to ask. You mentioned using cartographer for building a map, right? Which other tool could
Yes.
you have used? On the basis of the courses,
Mm,
the course itself, which other tool could you have used?
for the basis of the course, I only use the cartographer. So that's I think that's the most suitable way that I use. So
Yeah, it's the
I
one that's
didn't use
used
any
more
of.
often. Yeah, there is another one though that we can use. It's just that is popular with us, but there is another one.
Oh, I think I a little bit forgot about that. Yeah,
Slim Toolbox. Yeah,
yeah. So yeah,
Slim
for the
Toolbox. That's
cart,
the other one. Yeah.
yeah.
All right, and then the
So
other thing I wanted to ask you is concerning behavior trees, right? Can you explain to me in more detail what are behavior trees and what are they responsible for, right? How do they serve in the functioning of the robot?
so basically, let me open up the ones that I did. So basically, the it control the parameters that we will use for the navigation. So there are a lot of plugins that are used. So
Mm-hmm.
but all of these files are actually the default that the courses gave me. So uh, I didn't really change a lot of parameters. So
Yeah, yeah,
yeah.
yeah. No, it's fine. I was just trying to get your general overview of what do you think behavior trees are and what do they do, right? It's on the basis of what the robot is doing, right? If you're going to generalize about what behavior trees have to do with our BT navigator in general, what would that be?
Basically, from my knowledge, is to execute the various robot behavior. Like for example, we want to navigate in this case.
Mm.
So yeah, there's a
So
lot of things that
I see. I see. It's
yeah,
almost like to just put a general blanket term of it. It's almost like a state space kind of system, right? So the robot can
yep,
either be moving forward, rotating, turning right, turning left, path planning, right? So behavior
yes,
trees they kind of categorize the things that the robot will do in the course of getting to the goal, right, or to the goal post. Let's say that. Um,
yes.
yeah, but just a general overview there. Then the other question I wanted to ask you is can you explain to me the logic behind your custom interface, right? The service. What do you think is the main importance of creating that interface?
All right, so let me open up the service that I've made,
Mm-hmm.
the message, the interface. So the first is the request part. Basically, it contains the label of the spots, which is the corner one, corner two, and the pedestrian.
Mm-hmm.
And the response that it's given is basically, if it's successful, then it will uh, give the true statement.
Mm-hmm.
Where and for the service itself, the service server, let me open up that part. It's in the localization in the spots to file.
Mm-hmm.
So basically, it's subscribed to the AMCL post topic,
Mm-hmm.
which contains the coordinates.
Mm-hmm. Okay.
And in the next part, it create the service server
Mm-hmm.
named safe spot. Basically, what we called previously, like over here, there's
Mm-hmm.
the call safe spot. That is the service name.
Mm-hmm.
And basically, yeah, it is extracting, I would say, extracting the coordinates and then putting it in the text file.
Oh, so it's
So that's
almost like
basically,
creating a channel of communication, more or less, of how the data will be processed. Is that what you are implying?
yeah. Basically, I can just echo the topic of the AMCL post,
Right.
but we're not gonna use everything out there. So basically, I only want to extract the position and
Okay.
the orientation.
Uh huh. Uh huh.
As you can see in the text file, let me open that up. Yeah, these two are the only things that I need for the navigation.
Okay. Okay. So so your custom interface is responsible for making sure you get those things and only those things. Is that what you?
Yes, that's correct.
All right, all right, all right. I think that's all on my end, Ben. I'd like to congratulate you for very clear project, and also showing us what you did, why you did it, and general clarity of the overall going about. And even though we had the robot collide a little bit, those are
Yeah,
the perks of moving obstacles, right? So it is it is important to take these things into consideration to think about, okay, how can I make it better
yeah,
next time, right? If you had the opportunity of making the obstacle avoidance algorithms better, what would you do better in relation to the obstacles that it encountered? But it's just things to keep in mind. But very well done, very well done. I really loved it, and would highly encourage all those who would like to try to come and do so. So you just hang on. We'll wrap up here and then we'll finish our conversation on Zoom. Okay.
right.
All right, everyone. So this was Ben's presentation. Very warm, well done to him, and would like to thank him for making the taking the courage to come and do the presentation. And for all those who'd like to try the courses we offer certification on, we highly encourage you to do so, and then you can come and also give a presentation and demonstrate your understanding. And until next time, keep pushing your ROS